So I want you to write on your piece of paper LE, Alchemy of Pennies. And what you're going to do is you're going to explore what the composition of a penny is and try and be able to identify whether the penny is gold or not. When you did the changes for the penny, it started off in this copper color here, and then you put it in the zinc and sodium hydroxide solution, changed to the silver color, and then you added some additional heat with a Bunsen burner, changed to this gold-like color. So it's probably important to know what a penny is made of before we figure out whether we actually made gold or not. So what we're going to do is we are going to look at a penny that is in some hydrochloric acid. What I've done is I've etched my penny. If you look at the penny right here that I'm pointing to, I took a metal file, this metal file right here, and then I etched the penny. Obviously this is a copper color on the outside, and it is actually copper. You can look that up at the US Mint. But when you etch it, you get this silvery metal on the inside, just like the same silver color that you saw coat the outside of the penny. Right now we see evidence of a chemical change. You guys see bubbles coming from the inside of the penny, believe it or not. And that's because what I did is I took a metal file and I etched it right on the edge of the penny, very delicately. And I put it in the 6 molar hydrochloric acid, and you see evidence of a chemical change. Let's go ahead and write down what that chemical change is. Believe it or not, we could do an analysis and see that the penny is actually reacting on the inside because it is made of zinc, solid zinc. And it's of course reacting with hydrochloric acid, which is dissolved in water, so I'm writing AQ after it. Then the arrow shows that these are my 2 reactants. They are reacting to produce products. And the 2 products are zinc chloride, which is salt, so I'm making salt water, and hydrogen gas, which I could collect and I could ignite because it's very combustible. You are actually going to be doing that in this class. You are going to be producing hydrogen gas and reacting it. And it's actually kind of cool. You get a big boom. So anyhow, that's the reaction that's happening right here. So it turns out that the government has gotten cheap on all of you because the penny's not made of solid copper. You can actually go back before 1982 and it will look like this. Let me move my penny so you can see them more clear. So this is a modern penny on the top. You can see the silver streak, right? And then you look in the bottom one, see how I scraped it? You can see the edge of the penny's all nicked up. Yeah, what I did on the bottom is I did the same thing. I took the metal file to the guy. And it doesn't have silver, at least not as noticeable. It turns out before about 1982, pennies were mostly made of copper. Then the government started putting zinc on the inside of the penny and just copper coating the penny. So what it actually looks like in terms of the penny, we have 2 types of pennies. We have before about 1982 and then about after 1982. And before 1982, pennies looked like this. They had a lot of copper on the outside of the penny. Copper, copper, copper. Cu is the symbol we use for copper. And then on the inside, it was a lot of copper. They had a little bit of zinc, but mostly just copper all around. And I'll draw a box showing that that's the actual inside of the penny. There was zinc mixed in. And that's because the penny was 98%, oops, let me write that out more clear, 98% copper and only about 2% zinc. Not writing that quite right. So about 2% zinc, 98% copper. Now, after 1982, the penny started looking like this. And I'm going to draw this a lot better because I got out my red pen. What ended up happening after 1982 is they just had copper on the outside. It was like a zinc sandwich. The zinc was on the inside of the penny. So it was Zn, Zn, Zn on the inside. So most of you in this class were given a penny that was made after 1982. And what happened is the zinc, when you put it in the sodium hydroxide solution, coated the outside of the penny. Zinc went around the outside. And that's why it looks silver. Zinc looks exactly like silver. But then, after you coated it, and now it looks silver, what you did is you took that penny and then you added heat to it. You put it on a Bunsen burner, like this. And there was a change that happened again. And the change was that you started forming something that looked like this. Looked gold. So it's going to be a combination of zinc and copper on the outside. So he's got zinc, copper, zinc, copper, zinc, copper, zinc, copper. We have a name for a metal that's a combination of two metals. In fact, I'm wearing something that's a combination of two metals right now. It's this one right here. It still had the zinc core on the inside, so you can still scratch your penny and react it with acid like I'm doing. But there's a name for when you mix metals together. Does anyone know the name of something where you mix more than one metal together and form something like this? This is actually tungsten and steel. And steel is a combination of iron and oxygen, so this is basically iron, oxygen, and tungsten. Anyone know? This would be a hand up thing. Anyone know the name of a mixture of metals? Oh, I'm surprised. Raise your hand if you actually know this name that I'm writing here, an alloy. How many of you have heard that? So an alloy is a mixture of metals. And the mixture of metals that we made, raise your hand if you know this name, it's called brass. How many of you know brass? All right, cool. Brass is actually a combination of copper and zinc. Now, how you get different alloys is really important because the percentage of how much of you have of each metal determines the properties of that metal. So some of you didn't have as brilliant of a gold-like color as others. And that's because you didn't mix them quite right. I mean, you didn't have quite the right percentage. You may not have had enough zinc on the outside to begin with, or you may not have added enough heat. So you guys can actually make things that look like gold, and that's because you're forming an alloy, which is brass, which is a combination of zinc and copper. And you can show that the inside of the penny is made of zinc because you can react it with hydrochloric acid, and then you'll get a hollow penny on the inside if it was made after 1982, and it's going to float. So what you can do in this class is that you can take your penny, and I'll give you a metal file. You can etch it, and you can walk away with actually a hollow penny. It's actually really cool. And I'll drop it in the hydrochloric acid for you guys. So you can bring in other pennies as well, and other coins as well, and you can see what happens with the reaction with hydrochloric acid. The key thing is to remember is that the acid, see how it's reacting with the zinc on the inside, but not that copper layer on the outside. And it's really cool. You get this weird shell on the outside of the copper. So, how can you prove that it's actually not gold besides just doing that chemical reaction? Well, there's another way you could do it. Let me show you right now. So what I'm going to do is I'm going to pull up the PowerPoint that we began with, and I'm going to show you an old dead guy. Here's the old dead guy question. We're going to be looking at Archimedes. Come on, there we go. Archimedes was an ancient Greek philosopher, mathematician, engineer, and the rest, astronomer. And the myth is he was challenged by a king as to whether or not the king's crown was actually gold, because back then they knew about brass. They knew that brass was a mixture of copper and zinc, and that it looks the same as gold. And the king wanted to prove that what he had was not zinc and copper, but instead was pure gold. So let's talk about some of the properties of copper and zinc making brass in comparison to gold. You do not need to record anything down until I tell you guys for the notes. Now, brass is an alloy. It has a particular density. You can look at gold. Brass is zinc and copper blended together, and an alloy is a mixture of more than one metal, which hopefully you guys already wrote down from the notes that I was writing in the beginning. Now, how can you test whether it's gold? You can hammer it, you can drop it in water, you can weigh it, you can measure it with a ruler, all sorts of things. Well, there's some important properties of gold you need to know. Gold's really malleable. It's really flexible. In fact, if you have a gold ring, it's not all gold. They mix it with silver and other metals, just like mine's mixed with the one that I was showing you earlier with tungsten and steel, and that's to harden it. But the most important thing is that it's heavy in comparison to similar sized materials. It's very dense. Let's talk about this. Heavy is what we call mass in chemistry. Size, well, we can measure size with a ruler, but when we have size squared, cubed, it's what we call volume. So mass and volume, the ratio between those two is what we call density. You can probably watch some movies where they're carrying around gold bars, and if you see anyone carrying around a gold bar like over their head, that's stupid because it's a really, really, really heavy material. So what Archimedes did is he jumped in a bathtub and he came up with this idea. He's like, hey, when I sit in the bathtub, I can displace the water and I can measure how much space I take up. You can do the same thing with your penny, and that's what we're going to be doing in the future. Is you're going to take your penny, you're going to measure its volume, and then you're going to measure its mass, and the ratio between those two is density. all of you've learned about density in this class. Your homework is to see what you already know about volume and density, because density is the only way we can prove whether or not it's gold. So your homework today is to actually take volume and density, this worksheet, and you're only going to be doing part 1 and 2. This will probably take you 15 minutes at most. You need to answer your questions showing your work. You need to do it on a separate piece of paper. There's only 8 questions, and believe it or not, they're all word questions. We're not even getting into the calculation piece. Do you guys have any other questions about that?